Good morning, everyone. It's really nice to be here with you, and thanks so much to the organisers for putting together this great programme and for inviting me today. So I'm going to be talking about a study we did a few years ago using virtual reality with autistic participants, in which we investigated the experience of the bodily self. So first of all, what do I mean by a self? It's probably a good place to start. Well, you know, it's something we all have expertise in, of course. So we all have a self, we all are a self. But usually when the word self is mentioned, most people would think of something probably like their personality or their identity. But these are actually quite high-level aspects of self. And the self is in fact multi-layered. And what my research as a whole focuses on is trying to understand what is the self in its most basic form. So what is the foundation of self upon which all of the other levels of self might be built. So if you think about a few possible definitions of self, of how one might define oneself, the first thing that usually springs to mind, as I said, would be describing aspects of one's personality, the things that you like, the habits that you have, the things that you do, but perhaps trying to become a bit more minimalist about it. You might describe the self just as an entity that seems to persist over time, that seems to be continuous with an entity that was conscious at a previous time. So I feel like I'm the same self right now as the self who went to sleep last night, as the self who went to Wales at Christmas, and so on. So there is that continuity of myself across moments, across even weeks and years. And that continuity, of course, requires autobiographical memory, so the ability to remember previous experiences that myself had, and also to project myself into the future. But, you know, scientists and philosophers, we always want to kind of reduce it down and reduce it down. So one very sort of minimal definition of the self that's quite popular in philosophy and some aspects of neuroscience is that the self is simply the subject of conscious experiencer. So the self is the experiencer to whom and for whom things happen. So in other words, if you think of any conscious experience you might have, having the taste of an apple, feeling bored, hearing somebody's voice, feeling water on your body in the shower, all those conscious experiences are different, but of course they're all united by the fact that it's always yourself who is having that experience. So I think that's a really key definition of self. And there is also the self, finally, in relation to the body. So myself is an entity that seems to inhabit, that seems to own, and seems to control a body. And that's the focus of my research, is this aspect of self, the bodily self, which I believe provides the foundation for higher level aspects of self. And one key aspect of the bodily self, which itself has different components, is this feeling of body ownership, which Sean spoke a little about in the last talk. So your brain, of course, has to determine which body in the world is you, which might seem like a sort of a trivial thing to achieve, but it's not that trivial. It's a problem that our brains have to solve, not just once, but actually every moment that we are alive. And how does the brain figure out what part of the world is you, what part of the world is your body? So of course it receives a huge amount of information from your body, from different senses, from different bodily parts. And yet, of course, what we experience is not just a miscellany and a kind of mishmash of signals and body parts. We experience something coherent. We experience one single individual self, one body. But how do we go from this to that? Well, there must be some kind of combination, integration of all of this information to give rise to that coherent experience of the single bodily self that most of us enjoy. And how does the brain do that? How does it make sense of all of these different signals from different body parts and different modalities? So a kind of really simple example would be the case of where there are many hands. How does my brain figure out which hand is mine? Well, I could, for example, decide to move my thumb, and then if I see this thumb moving at that moment, then that is telling my brain that must be my thumb. Or if I feel a touch on my arm, at the same time seeing a touch on the arm, that's telling me, okay, that must be my arm. So basically what the brain is doing, of course, is it's trying to detect correlations between the different senses. It's trying to detect matches. So coming now to the self in autism, this has usually been studied at, I suppose, what I call a sort of a higher level aspects of self. So, for example, Chris Frith has suggested that differences in the representation of the self might explain some of the differences in social functioning that you see in autistic individuals. And there are some examples of differences in self-representation that have been found, for example, in self-referential cognition, differences in the use of personal pronouns and in self-face recognition in some autistic individuals. And it might be that these differences in self-processing are partly attributable to lower level differences in the multisensory representation of the body. But how can we study how this feeling of body ownership arises? How can we study the multisensory representation of the body and whether it's different in people with autism and with neurotypical participants? So one common way, of course, of investigating body ownership is by using body illusions, which have been used, of course, a great deal in neurotypicals. So one example being the rubber hand illusion, which probably many of you have heard of, where you have a participant sitting, looking at an artificial hand. His own hand is out of view, and then an experimenter is tapping the rubber hand and the real hand at the same time. So we'll just have a quick look at that video. So you can see the experimenter is touching the same finger of the rubber hand and the real hand at the same time. So that's what we call a synchronous condition. Oh, and then he goes to stab the rubber hand and gives the participant a bit of a fright. So for not everybody, but probably most people will experience some degree of an illusion with this, and you start to feel like the rubber hand is actually part of your body. So you start to feel a sense of body ownership for an artificial entity when those taps are in synchrony. If you tap the rubber hand and the real hand out of time, so they're not corresponding, then that illusion is not so strong. But I'm interested in really ownership of sort of not just a body part, but of the whole body. So we're going to move on to that. But there have been some studies of the rubber hand illusion in autism. Not very many, but a few. So one study showed that the rubber hand illusion takes longer to induce in autistic children, and also that children who demonstrate lower scores on empathy measures are less likely to experience it. It's found that autistic adults do experience the rubber hand illusion, but one aspect of it, which is what we call the drift in hand position. So one measure of the illusion is that after the tapping, you start to feel like your real hand is located closer to where the rubber hand is seen. So they show less change in their felt hand position. So there seems to be there a reduction in the illusion. But I'm interested in the ownership of the entire body, and to do this we need a different kind of illusion. Another aspect of the bodily self, apart from body ownership, is the feeling of where the self is located in space, which is kind of a weird thing to think about, but if you think about it right now, you know, where does your self seem to be? It might be a bit different when you're in a Zoom call and you can see yourself on the screen, but usually if you think about, you know, where is yourself in the world? Well, most people would say, well, myself is obviously where my body is. But if you try and narrow it down, would you say that yourself is in your hand, in your foot, in your head? You know, where does it seem to be? Well, surveys have shown that most people would say either, some people say that the self seems to be in the heart, sort of chest region, but the most commonly reported location for where the self seems to be is sort of in the head, and that's usually where it feels like it is for me. So I don't mean the self really floats around the body, but that's just our experience of where it seems to be, and that's something that of course our brains have to generate, and it's something that goes wrong in fact in some neurological conditions like out-of-body experiences where the self is experienced in one place and your body seems to be in a different place. So is there a way of altering this experience of self-location? Could you experience yourself in a different place to your body? And could you modify ownership, not just of a body part like the hand, but the entire body? And if we had an illusion that could do those things, then that would enable us to study, again, the representation of the bodily self in the brain. So the illusion that we've been using to investigate this is the full body illusion that you might have heard of. And I just got a quick video of that. As Sean said, it's often easier to understand these things in videos. I'll get to the right place.
In order to trick or to preclude.
I'm not sure if you can hear any audio of the, can you hear the audio? Yeah.
Yes, yes.
Of the experimental subject. We had a camera not in front, but in behind the subject, 2 meters behind, who was filming the stroking, and in real time projected this information to a head-mounted display, which was in front of the subject eye. So all the subject was seeing is the stroking, but now as if he or she was standing 2 meters in front. So this gives the strange sensation that you feel your touch at your back, while at the same time you see your own body being touched by 2 meters in front of you. And some of the subjects reported that they very strongly felt the touch rather at the position where they saw being touched than at their back, which was one important evidence of linking experience to our experimental setup. And there was a second measure when after the 1 minute of stroking, the subject eyes, we displaced them to another position in the room, and then we asked them with eyes closed to walk back to the position. And when they were doing this, they actually did not go back to their real position, to my position right now, but rather were closer actually to where they saw the body. The out-of-body experience is one example where such an own-body illusion is apparent.
Yeah, so it's a pretty strange illusion, but it's actually a very simple virtual reality setup. As you saw, so you have a camera behind the participant, they're wearing their virtual reality headset, so they can see what the camera sees. So that it seems as though you're standing behind yourself, and then you have that experimenter who's tapping you on the back. So you're feeling the taps on the back, seeing your double standing in front of you being tapped on the back. And then, like in the rubber hand illusion, you have both the synchronous condition where the taps are in real time. So the touches you feel on the back are seen at the same time and the same place on the virtual body in front of you. And then the asynchronous condition, which is a control condition, is where there's a delay in the camera. So the taps you feel on your back are not in time with the taps that you see on the virtual body in front of you. So this was first published in 2007. There's been tons of papers since using the same kind of method. So it's been replicated many times, but the usual finding then is that you have this shift in where yourself is experienced to be. So when the taps are synchronous, when you're seeing the taps on the virtual body at the same time as feeling them on yourself, you start to feel like yourself is located closer in space to where the virtual body is. So this drift forward, which is significantly different. This is a group of around 20 participants, significantly greater in the synchronous illusion condition. And then if you have a questionnaire and ask people if they agree or disagree with various statements, the key one is question 3. I felt as if the virtual body was my body. People agree more with that statement in the synchronous condition than the asynchronous condition. So coming finally to my study, what we wanted to do is to find out whether autistic individuals would experience the full body illusion in the same or a different way. And the reason for doing this would be, well, if we found differences in the susceptibility to this illusion, this would suggest there are differences in the multisensory representation of the body. So we had the same setup as had been used many times in neurotypicals. Participants standing in front of a camera, and then they view themselves from behind, being tapped on the back. We tested 22 autistic participants and 29 neurotypicals, and tapped them on the back in each condition just for 2 minutes. And we tested both the synchronous condition, where the tapping is at the same time, and then the control asynchronous condition. We also had another control condition where they saw not their body, but an object that was being tapped at the same time as their body in the synchronous condition, or at a different time. So with neurotypicals, you tend to find the illusion doesn't happen, or it's much weaker usually in this condition. So we measured self-location, as you saw in the video. It's kind of a difficult thing to measure, but after the 2 minutes of tapping, the participant had to shut their eyes. They'd be brought backwards by 1.5 meters, obviously marking on the floor where they'd been standing. And then they're asked just to try and walk backwards to where they thought they were standing originally. And you find that usually people won't get to exactly the same place. They might undershoot or overshoot, and then you can measure in centimeters where they arrive at. So that's our measure of self-location. And then we also presented a questionnaire with various statements, including the key one: I felt as if the virtual body was my body, or I felt as if the virtual object was my body, and they agree or disagree with that. And so this is what we found comparing the neurotypical and autistic participants. So for the self-location measure, we found that the drift in the synchronous condition as found before is much greater, significantly greater than in the asynchronous condition. So they seem to locate themselves closer to the virtual body. But you don't find this difference at all in the autistic participants, and that was significantly different. And you don't find the same drift in self-location in the object condition as we expected. So for this measure, there is no evidence of there being an illusion in the autistic participants. And then also looking at the questionnaire measure, you see the usual finding of greater self-identification in the synchronous condition than the asynchronous condition. So they felt like the virtual body was their body more in this condition for neurotypicals, but you find no difference at all between the synchronous and asynchronous conditions for the autistic participants. So that was, we thought quite striking. And then looking at the whole group together, so merging the autistic and neurotypical participants, we ran a couple of correlations. We found that autistic traits were negatively correlated with the illusion strength, with self-identification with the virtual body. So the higher number of autistic traits somebody had, the less they tended to identify with the virtual body. And then we found the opposite sort of correlation for empathy measure, the affective and cognitive empathy questionnaire. So the higher somebody scored on the empathy measure, the more they tended to identify with the virtual body. So essentially we found no susceptibility to the full body illusion in autistic participants, neither on the self-identification questionnaire measure, nor on the self-location drift measure. And as I showed, we had those correlations between autistic traits and empathy and the strength of the illusion as well. So what this suggests is that this reduced susceptibility to the illusion is suggesting that the representation of multisensory bodily signals in autism must be somehow altered. And we can't really state this confidently with this result. We need more studies, of course, but it could be that these differences in bodily self-representation at quite a sort of lower level might underlie some of the differences in self-representation that have been found at higher conceptual and linguistic levels in autistic individuals. And also these findings of links between illusion susceptibility and empathy might suggest again that the multisensory representation of the body is somehow related to social cognition. And coming back to sort of implications, I suppose, for virtual reality. So the fact that there is a reduced susceptibility to the illusion, or almost no susceptibility to it in autistic participants, suggests that it might be harder to achieve feelings of presence in virtual reality in autistic participants. I don't know if there have been any studies in the VR field about this, but you know, what we in cognitive neuroscience call body ownership is very much what people in the VR field are sort of, you know, calling when they talk about presence. In particular, of course, if there's an avatar in the virtual reality environment, the more you identify with the avatar, the more present you feel in that environment. So it might be that, yeah, the presence might be more difficult to achieve for autistic participants, but I'd be interested to know if anyone in the audience has come across this. So I just want to acknowledge Carolina Moule, who ran the study as part of her PhD project, and to thank all the participants of our study. You can find this publication of the study in the journal Autism, and thanks very much for your attention.